Good afternoon, everyone. I think it's time to start. Welcome. It's great to be at a real conference with real people again. I hope you're as excited as I am. Welcome to this talk on building modern diagram editors with Eclipse GLSP and why it is, in my opinion, crucial to be as flexible and versatile as possible in a modern era and of next generation tool chains. My name is Philipp Langer. I work with EclipseSource, which is an open source service and technology provider. And we are building together with our customers different tools, domain-specific modeling tools, custom IDEs, business applications, and so on, based on open source technologies. And Eclipse GLSP is one of those technologies, and I'm happy to talk about that. Just in case you haven't heard about GLSP so far, GLSP is short for Graphical Language Server Platform. It's an Eclipse project. And it's basically a client-server framework that allows you to build custom diagram editors, as the ones that you see up here, with full editing capabilities and so on, based on modern web technologies. And it does so in a way that it can then that you can then integrate those editors seamlessly in arbitrary different deployment or distribution options, ranging from standalone applications in the browser, in Electron, but also in tool platforms such as VS Code or Eclipse Thea, or even the traditional Eclipse Rich Client platform. GLSP does that by adopting the idea of the language server protocol, which is, I'm sure you've heard of it, really popular and more or less the de facto standard for building language support for modern tools. But of course, GLSP applies this idea and adapts this idea to diagram editing and graphical languages. And with that, you gain the same benefits, which is basically it enables the development of browser-based diagram clients, whereas the front end is really focused on diagram rendering and user interaction. And the entire language smarts, model management, model manipulation, and stuff like that is encapsulated in a diagram server. So Eclipse GLSP is, as the name implies, an Eclipse project hosted on GitHub, so you can find it on this URL. And it basically provides you 4 types of components, which is on the first of all, a server frameworks. So you can basically use these frameworks to build specific diagram servers for your particular diagram language, either with TypeScript or Java. It provides a defined protocol that is, however, extensible so that you can add your domain-specific stuff on top. It provides a client framework with TypeScript, basically to define how your diagram shall be rendered, as well as how the user interaction should be implemented. And last but certainly not least, it provides platform integrations that allow you then to take editors that you've built with GLSP to integrate them seamlessly into, for instance, Eclipse, VS Code, or Eclipse Thea. Basically, the client-server interaction is as very similar to LSP for programming languages, but of course there are a few differences. So you can think of it when you want to open, for instance, Eclipse Thea and double-click on a file. That, of course, is in the Eclipse Thea platform. So the platform integration, first of all, triggers the opening or the creation of an editor in which a GLSP editor is then configured. This GLSP editor then initializes the diagram server with arbitrary information that is needed for the server in order to identify what needs to be loaded. Typically, it's a URI and a diagram type. Then, based on this information, the server has then the responsibility to load the source model. And the source model is really the data source, the information that you need in order to create the diagram eventually. This source model can really be anything. It can just be a JSON file. It can be an EMF file. It can be an xtext-based file, or even live in model repositories, such as the one from emf.cloud or databases or REST. Basically, it just needs to provide the information that then the server can use to end up creating a so-called graph model, which is sort of like a structural description of how the diagram should look like. Rather not look like, but how it should be structured in terms of you have there are nodes and edges with types and with attributes and so on in order to control the behavior of the diagram. This graph model is then sent to the client, and then with the help of an excellent, cool open source framework also hosted by the Eclipse Foundation called EclipseSource, this graph model is then translated into actual SVG that can then be rendered in the browser. On top of that, SVG being rendered in the browser, there are then, of course, client-side editing tools that react to mouse events, keyboard events, and so on, that can then lead to further actions that are either then handled locally in the browser or that are sent back to the diagram server. So for instance, if you create a new node, then the server, the client will trigger some sort of editing tool, will trigger an action requesting the operation to be applied on the server. The server applies it then to the original source model, whatever that was, like a REST service or an EMF model, and then regenerate the graph model in order to update the rendering eventually on the client. Of course, all of that is extensible in a way that you can also build your custom editing tools, your custom actions in order to add to your domain-specific functionality and also adjust the default behavior that GLSP provides. Right, that's about a rough overview. Let's have a look at how that actually feels like in code and in real life. So basically, I will be showing a demo where we are using Eclipse Thea as a tool platform, basically running in a browser. And we will be using a Java diagram server, talking to a plain JSON file, super simple in this case. And the two main entry points to be configured for or to be defined for such a diagram editor is two things. It's on the one hand side a server module and on the other side a client module. So let's first look at how these modules look like. So first of all, starting with the diagram server, essentially what they are based on is all dependency injection. So what you start off from is you choose one of the most fitting base modules that you can then use as a superclass for your specific module for your diagram language. In this case, since we are just dealing with JSON, we take the simplest one. And what you then need to specify is just a workflow diagram ID, so basically an ID of the diagram language that you want to define. And then at least you need to provide these three things, which first of all is a diagram configuration, which specifies which graph element types, so that's basically what we've seen here before, which types you are going to be using in this server, and how they should behave on the client. For instance, are they deletable? Can they be resized? Can they be, I don't know, moved and stuff like that. Once you've defined that, then you need to specify what we call the G model storage or the source model storage. And that basically specifies where the server, that implements where the server actually reads your source model from. And as I said before, that can be very different. So you need to provide an implementation to obtain this source model from some arbitrary source. And in the end, then you need to provide a G model factory. That's an implementation of how this is then translated into the graph model. And that's basically the minimal thing that you need to specify in order to be able to first load and render a diagram. On top of that, of course, you can then specify operation handlers. That's basically implementations of what should happen if the user triggers some sort of operation, like creating a node, deleting an element, and stuff like that. And you can then add additional action handlers reacting to domain-specific events, for instance. You can add validation and stuff like that. So that's basically then optional. If you want that feature, you have to provide an implementation by following one of those interfaces. So let's switch now to the client. On the server, we've already specified where to read this model from, how to translate it into a graph model. So basically, wrong VS Code, this one. Basically, all that is left to do on the client side is to specify how this graph model shall be rendered in terms of SVG. And we do that, as I mentioned before, with Eclipse Sprody, where we basically then only need to specify, okay, if there is a node with the type task automated, then I'll use this view implementation. If there is some other, then I use another view implementation. Basically, a view implementation then is nothing more than a render method where you get the graph node as input and you provide SVG from that. That's basically it. Right, so let's have a look at that in action. So in this browser, you see a Thea application where we have registered this server that we've just seen and the client that we've just seen for the WF files. So as soon as I double-click that, we see that we get a nice looking diagram out of it, basically reading this from the WF file. And here we can then start editing. Maybe let's create a task. We can double-click labels and start modifying it. There is also label edit validation then on the server that specifies whether the label that you've entered is valid or not, and so on. You can create edges and stuff like that. Of course, there is also much more features, like you have things like validation. Let's maybe trigger that once here, where you get then error markers. You can also then look at those in the problems view and navigate across those markers and stuff like that. Then there's auto layouting and so on and so on. So there's many, many more features that you can then implement based on the base protocol and the base frameworks on the client and the server. So for instance, when I trigger the auto layouting, it has now changed. Of course, there's also undo redo. Since we didn't see it changing, I'll maybe undo the change here just to show it. Yeah, that's basically a rough overview of the extent that GLSP provides you with out of the box and that you can then use for your specific language. So basically what's new with this project, GLSP has been used in production now since a few years in several products. But a few months ago, thanks to the work of 26 contributors, which we are very thankful for, we were releasing the first 1.0 release a few months ago, leaving the incubation status. And with that, there have been a couple of changes and enhancements, but I wanted to highlight these three listed on this slide. So first of all, there has been a lot of API stabilization, obviously, for 1.0, and quite a big server API refactoring with the goal to basically separate the server framework from the actual source model technology, basically separating those two entirely so that you are entirely flexible on which kind of source model, whether it's JSON, EMF, or a REST API, you're actually going to use. All this functionality that has been already existing for those source model technologies has been extracted out into reusable modules that you can then optionally use for those use cases. Second of all, there is an entirely new component which is called a node-based server framework. So originally, GLSP only had a Java-based framework. Now there is also a node-based framework for building diagram servers. And that's really nice because you can then use the same language on the client and the server and have a much more homogeneous development setup. And also in certain use cases, it alleviates a lot of runtime requirements, right? So when your target is a VS Code extension or an Eclipse Thea extension where you don't have a lot of control over your runtime at the user, then you can expect Node to be installed because otherwise these tools wouldn't run anyway, but you cannot expect a JVM to be installed. So basically, this allows you to remove a JVM requirement altogether. Right, and last but really certainly not least, there has been a lot of improvements in the area of documentation. And also there is project templates that you can basically just use and start from for your combination of technologies that you are looking at. So for instance, you want to start a VS Code extension with a JSON backend or model, source model framework, then you can just pick this and start and be running in no time essentially. Right, there are many more changes, but I highlighted those also for the reason because what I've observed in the last years basically is that GLSP has been evolving more and more and has been requested by the community to get more and more flexible. And also the first two items at least, they reflect this need for flexibility. So what I wanted to do in this talk is reflect a little bit on this requirement and why there is why it's so crucial to be as flexible as possible in this area. In my opinion, looking at the projects that are adopting GLSP and that have been pushing for those changes to be more flexible, in the end, I think when you think of it, it's also true for the language server protocol. It's not just about getting onto a web technology stack or into the cloud. Of course, this is a huge motivation for instance, switching from GMF to GLSP or from I don't know, some technology to switching to a technology where you can use LSP. It is much more than that. It's basically an architectural paradigm shift. And looking at the modern tool technology stack like VS Code or Eclipse Thea, it is much more fluid and diverse than it has been originally, for instance, in the Eclipse IDE market. So when you think of it, for instance, VS Code or in Thea, we are dealing with ephemeral workspaces that are started in the cloud for you just for one use case, interacting with some remote file systems and so on, remote runtimes and so on. But you want to exactly use the same tool also on your desktop to interact with your local file system. But then you want to exactly use the same tool and spin it up, for instance, for a simple reviewing purpose, just running in your browser without a cloud infrastructure at all, right? And this is all the same tool platforms and the same components that are integrated with those tool platforms. And I think that's a huge improvement and really opens up many, many opportunities. This new modularity and combinability. And of course, all the tools that want to integrate with such platforms, they need to be just as versatile and combinable and modular as well. And this is, I think, what pushed GLSP more. And even more than that, diagram editors are by nature very specific to a specific diagram language. So that's even more request for flexibility if you compare it, for instance, to programming languages where we just deal with text. Because different domains with different modeling languages, they have completely different ways, different types of data sources, maybe not only one source, but many sources that they want to combine. They have different workflows, starting not at a model, but starting somewhere else in another tool, exporting information, then processing it, showing it in a diagram, changing it, and handing it over to the next tool, and so on. So there is a lot of requirement for integration and domain specificness, which is even more than the ones that we see in the normal IDE market, I think. So what I did in this talk is basically taking taking the architecture of GLSP and going through every component. We have here 4 loosely coupled components in GLSP and highlight one of those flexibilities and how I've seen it being used. So starting with the most obvious, of course, is the client side that is responsible for the rendering. And here the GLSP evolved more and more towards giving users direct access to the excellent base technologies for defining the rendering, but also the user interaction. So basically, that doesn't only require to have full control over how a shape looks, but also how you interact with the diagram, how you specify editing tools, and so on. And basically, there is, by choice, no limiting abstraction layer in the middle, so to give you full access to the technologies that are super flexible on the one side, that are super well known in the community, and to benefit from the full power. This has also great implications on the debugging experience, because you can exactly use the same tools that are very much used in the web development. So let's have a look at the short demo. So I'll open up this editor again, maybe just don't save, reopen. So basically, one thing, we've seen how we can create an edge. So basically, you first maybe create a new task. You can then select an edge type and start somewhere. In many tools, many domains, this is maybe not what you need, but you rather want to just start dragging from a node. In GLSP, you can do that by just adding an additional editing tool where you can implement the behavior yourself, right? And so I did that here when I hit the Alt key and then start dragging in some place. Then I can directly click on an element and start dragging an edge. And I can even query the server to highlight all valid navigation targets, all valid edge targets. And then I used a funky disco 80s animation to highlight those possible nodes, and then I can select one and complete the selection. So this is a combination of using really cool CSS technologies, but also custom editing tools. Also, the SVG views can be entirely dynamic, so you can even react to zoom events and so on. So I can zoom in here into a certain manual task and see, who is actually responsible for this manual task. And then at some point, some face appears, and then you know, okay, it was this guy that is responsible, right? So someone brought up, it would be cool if I could now even zoom further and then other people's arrive, but I didn't do that for now. So that's a stupid example. No one wants to have my face in a diagram, but it was just an example of how flexible SVG is and that you can even make the rendering dynamic. Right, now moving on to the to the platform integration. So the platform integration is really only containing the platform relevant stuff. So so all the diagram specific implementations does not have any dependency to the actual platform like Thea or VS Code. However, the platform integration then allows you to use native APIs of the respective platform, like VS Code or Thea, to do things like editor registration, reduce global menus, platform-specific styling, and stuff like that. And the most important part is it's 100% extensible, so you're using the native API, and that's super important because a diagram editor, a workflow of a user, doesn't start and end at the borders of your diagram editor. That's just not how it works, right? So you want to integrate also not only with platform components like a file explorer, but maybe also your custom views that you have added to your Thea application, VS Code application, and integrate with that title. And you can do that in those platform integrations very, very easily. And the typical pattern is, of course, then that you can either from your platform integration send actions into your diagram client to change some state, but your diagram client can also expect certain functionalities like navigating to an external editor from the platform. And then, of course, there can be different implementations, one for Thea and one for VS Code doing the same thing. I don't have a demo here about VS Code integration. I will show one in the end, just to save some time. So now let's move from the client to the server side. I already mentioned that with a huge, or not as huge, but a little bit of a refactoring, we completely separated the model management from the framework in that sense. So you can basically have your server even interact with different implementations of a model management, whether it's the format, the structure, the modeling framework, whether it's a local file system, remote file system, and so on. But for the most popular choices, we provide ready-to-use base modules. So for instance, emf.cloud model server, and JSON. So with them, you get all the generic functionality already provided, but you can also choose to implement it from scratch for your particular use case. So have a look at the project templates. They already provide you use cases for those different scenarios. And this independence of the model management really facilitates not only migration from your existing way of dealing with models, but also, of course, in the future, if you want to change from EMF to something else, you can do so without affecting at least many parts of your diagram implementation. And last but not least, and I've seen that really cool examples of that, it also enables reuse across multiple deployments or distribution channels where some of your users are using local file system with EMF, but other users, they use these diagrams as documentation. They use then a REST service, and you can still reuse the same components except for the model management, and basically have a second model management implementation that then, instead of using EMF, reads this information from a REST service for providing documentation. Right, and last but not least, I already mentioned that there is a new server framework alongside Java. Basically, GLSP servers could have been implemented all the time with any programming language in theory. So since there is just a communication using some input-output like WebSockets or sockets and a defined protocol, but we haven't seen anyone starting one, I don't know, in Rust. So basically, people start from using the existing frameworks. And here, as I mentioned before, there is alongside Java now a new TypeScript-based framework, which has all the advantages that I already mentioned before regarding the development experience and the alleviation for the runtime requirement for a JVM. We still keep the Java language server, obviously, so it has been a lot in use by many different scenarios. It makes more sense to use the Java language server. So for instance, if you're dealing with EMF and so on, it has advantages, but you can alternatively also use now GLSP, the node-based server. I can also show it really quick, just to because it's fun, I guess. Here we have, I've already shown you here the Java server. So let's just kill it. Going back here, we now see, okay, the connection has now closed. And now I can go to the same implementation now in TypeScript, which basically looks structurally exactly the same. You still have a module, you still have your diagram implementation and so on, a diagram configuration and so on. And I can now start this instead, and then go back to the browser and refresh. I guess I didn't save before, but anyway, we reload from the file system, and it's working exactly the same way as the other server did. Right, so that's pretty nice. What is really special, I think, also is the deployment options. So basically, when you now look at all these different variation points that you have, there is quite a number of different deployment options, right? So there is even more. Probably that's just the ones that I know. That makes it super versatile. But it's not only the combination of technologies, it's also how you deploy these components at runtime. So for instance, in Java, if you integrate with Eclipse, it makes sense, obviously, since the JVM is already running for the Eclipse IDE, that you put it into the same process, but in other scenarios, like VS Code and Thea, you can put the server then not in the same process, but in a separate Node.js process. When you then transfer this VS Code application into the cloud or this Thea application, then this write part changes in order to run remotely in a Docker container. Then you can go even as far as separating again out the model management into a separate Docker container, which maybe even is then shared across multiple users, this Docker container. So there is lots and lots of options. By the way, if you want to learn more about how to deploy Thea-based applications in the cloud, there is a great talk tomorrow at 5 about exactly that topic. Last deployment option that I didn't show yet is in many, many scenarios, it actually makes a lot of sense to have no cloud infrastructure at all, right? So things like where you don't need a full-fledged backend, where you have a separate container being spinned up just for you, but you just want the browser application without any backend whatsoever. And that's super, I think, coming up more and more. And one very popular example of that is, I'm sure you've seen it when you are on GitHub somewhere. Let me just go here. You can just open any GitHub page and then hit dot, right? I'm not sure if it now works in this rather flaky internet connection. But what actually now happens is that you start a new VS Code instance just running in your, no it doesn't, but I have opened it before. And since we don't need an internet now for this to be running, it's safe. And it just opens a VS Code running only in your browser without any backend. So there is no language servers, there is no container that is running in the cloud. And now, since we have a TypeScript-based GLSP server and a different way of building it so that it has no node dependency, we can also even integrate a GLSP server running in such scenarios. So when I now open this WF file, basically it will work, hopefully in a second, exactly the same way. I guess it fetches some sort of things from the internet still. No? Okay. What a bad connection now in this case. 1 second, I can make it work. I think I have to show it because it's so cool. Switching to my mobile in 1, 2, 3 seconds. No, it's showing up. For some reason now it's here. Okay, I guess I have internet now. Yeah. This is how it would normally look like. So you basically get your extension here, and then running only, you get your VS Code instance here, running only in the browser. And then at some point you should be able to open basically your diagram editor. No, finally. Thank you very much. I would have gotten slaps in my office when I went home and said I didn't show this demo. So now it runs only in the browser and has exactly the same capabilities, which is, I think, really cool. And just to do some change, maybe let's add an automated task here. And we even have, of course, all the server-based validations and stuff like that. So that's super cool, I think. Right, with that, I come to a conclusion. Let me just check the time. Yeah, it's all more than time to come to a conclusion. So I think it's extremely important in this new next generation tool era that is currently starting to be as flexible as possible across all levels, to not only have a great user experience, but also to provide these different multiple deployment and distribution channels by reusing as much as possible of your existing implementations. So I invite everyone to try out GLSP, let us know your use cases, and just go to the project templates. It's now easier than ever to get started, but also feel free, of course, to contact us anytime. We have a booth, we have a booth right out there. You can visit us there anytime, and we have a Birds of a Feather session at 7:30 later today. So feel free to drop by and ask us any questions. But I'm also, of course, very happy to answer questions right now. Just one reminder, please, we were asked to ask you to evaluate the session, and I would be very grateful for any feedback that you can provide there as well. And now with that, thank you very much for being here, and let me know which questions you have. Thanks. Are there any questions? Yes, please. I can repeat as you prefer, but I can also repeat if you like.
The question is, how are the graphical information stored? Do you have, or does GLSP have some default setup like for format like the GMF does? And is it always separated like it was in GMF days, or can you also combine it? So is there also flexibility in this regard?
Yes. So the question is, how is GLSP dealing with the graphical information like coordinates, sizes, and stuff like that, which are not strictly speaking part of your semantic model? So basically, GLSP does not provide any limitations or put any limitations here. So you are responsible for, in the end, generating from your source model or source models a valid graph model that may or may not contain these coordinates already. And the same is true when you move something and you need to write it back to your source model, you decide where you put this information. So that's from a pure core GLSP point of view. There is basically, it's completely up to you how you do that. However, in many use cases, especially the EMF use cases, you need some way to store those, and you typically don't want to store that in your semantic model. And then instead of having everyone coming up with a separate model to store those, GLSP provides a notation meta model for you, which is, you mentioned GMF, which is much, much, much simpler than the one from GMF. It basically just has lists of nodes that can have sizes and positions, and edges that can have basically routing points. That's all that you can store there. Of course, you're free to extend it for your use case, but that's what comes out of the off the shelf from GLSP.
Thanks.
Welcome. Any other question from someone? We still have time. I think 2 minutes. Can even be a long question then. No? If there is no further question, then thanks again for being here, and make sure to catch us later if you can think of any questions. Thanks, and enjoy the conference.